so the sander that I'm actually going to use is a T99 Method A, and you guys will see that on your in the documents that I provided you. I know the last one said ASTM, but I'm just going to use the AASHTO T99. So what I did is I tore out a bucket. I'm going to take my sample, which is already wet. I'm going to get the whole mass of this sample. It doesn't necessarily have to be totally wet. It helps if it's drier, but we got what we got. So I have a total sample of 20.90 pounds. So now what I'm going to do is, because I'm doing a T99 Method A, I need to do what's called scalping it over the number 4. So what I'm going to do is I'm going to tear this bucket out now. So I'm going to come over here. And this is a number 4 sieve. We sieved out, or we scalped the rest of that sample for everything plus 3/4, or sorry, plus number 4. It's in this bucket. Turns out I tore out the wrong bucket in the first place, but here's the rest of that sample. So I tore out the pan. I have 0.44 pounds on top, so my weight retained is strong spot. The number 4 is 0.44. So all you need to do is come up with the individual percent retained. If it is less than 5%, which this should be, there is no correction factor. So if you look at the AASHTO or the ASTM, it'll have an oversized rock correction factor, but because we are less than 5% within the allowable limit, we are not going to use it. If this was more than 30% of the sample, then it would be considered too granular to test, and it would be a visual inspection test procedure as opposed to a nuke gauge or a sand cone. But we're obviously on that 5%, so I'm not going to worry about it. Positive. So this is the actual Proctor that we're going to run. So I have the mass of my mold right here. Notice that the color is off. The color, which I left somewhere that I'll find real quick right here, is attached to the mold when I actually run the test, but it is not a part of the actual volume. This thing is calibrated to be exactly 0.0333. Okay? So the color is not on there. So that's going to be my mold tear, and that is 9.487, and that will be consistent through all my trials. My volume as well, 0.0333, will be consistent through all my trials. So, what I am going to do now, I'm going to put the color back on. Set this guy down. I'm going to take my bowl. Right now, I am a little bit below optimum. I think I'm just going to start running the test now because I know I'm under, but that's also where I want to be. And I'm just going to add 2% until I get to where it is I'm trying to go. So what I'm going to do, I'm going to tear this bowl out. Here, all this in. On. Now I'm going to add 1% moisture to what we currently got. So I got 17.346, multiply that by 0.01. My new weight is 17.519 is where I'm going to try and get to. So I'm just going to add water until I get to about right there. So again, this is an arbitrary amount that I'm adding. When I say arbitrary, the amount itself does matter, but it doesn't matter in the sense of calculating my values because I'm going to get a moisture content at the end of each process. All I'm going to do, I have my 1%. I'm going to try and see if I can't get that mixed up decently well. So because this is a clay, it's not really going to want to mix, so I'm probably just going to pause it and get back to you guys when I'm done mixing. Alright, so like I said, I was running a AASHTO T99A. So that is a 4-inch mold I'm going to do 3 lifts or 3 layers with 25 blows each with a 5.5 pound hammer. Okay, that is the Ashto T99 method A. So I have my material mix. What I'm going to do is I'm going to take my Proctor mold down here and I'm going to fill it a little more than 1/3 of the way full, because I know that when I actually compact it, it's going to shrink. So I'm going to put that there. I'm going to put a bowl over the top just so I make sure I retain my moisture content. This is my Proctor 5.5 pound hammer. If you actually look at the spec, it says I am allowed to pat it down. Now I'm going to do 25 blows. Alright, that's 25. I'm going to scrape off the top, and I'm going to add about another 1/3. That's about there. A little more. Put it back on, and we're going to compact. Scrape the edges off. And now for this last one, ideally, if I were to do this just right, which I hope I will, I'm going to have between 1/4 and 1/8 of an inch over this top seam of where my collar is at. Let's see if I do that right. Normally I don't, because I don't run this test a whole lot. Normally I'm in the field more than I'm in the lab. I guess we'll find out. Now, if you also notice when I'm doing all these blows, I'm going in a circle around the mold, trying to get everything relatively evenly. So there's 25. What I'm going to do is I'm going to pick it up, bring it over here. And that's actually really not bad at all. I'm going to find a straight edge, which is probably over here. Broke the straight edge. Pause real quick. Alright, so I'm going to take my straight edge, and I'm going to compact and saw off all the extra, because I want to get exactly to the top of this mold and no more. If I get more, then I'm outside of that volume, and that is not the goal. I want to make sure it's as compact as it can possibly get to the inside of this. That's it. So I think that's going to be close. Give it a good shake, get everything else off. Tear out my scale, weigh it again. So on this paper I said plus 1% is what I did. And my mold plus moist soil is 13.034. 13.034. And now what I'm going to do is I need to get a moisture content out of this guy. This is the, I guess, the fun part, you could call it, if I can get that off. Pause real quick. So I'm going to take this guy out, right down there, put it on its side, hit it really hard, and hopefully it comes out. There's one lift, and there are my 3 lifts. Now with clay samples like this one, they're going to be a lot of fun once I do get to compaction, because, well, that one came out on my 2nd or 3rd hit with the dead blow. I might end up using this, which is not always ideal. But what I'm going to do now is I'm just going to put a tag in there. My tear is 0.688. We'll grab a portion of one of those. If you actually look at the spec, what it's going to say is if this thing came out in a total, you're supposed to cut it in half, and you're supposed to take half of it. Now, because I didn't make a whole lot of material to do this slab, because this isn't an actual, this material was already used to run a Proctor on, so I just basically just put a bunch of leftovers together. So I'm going to try and conserve my material. But again, if I was actually running a Proctor for a client, you cut the mold in half, and you take a portion of basically what you extruded or what fell out of that. But it does come out of here. So now my new moisture content is my new weight and pan is 1.261. I'm going to add a tag to this. 1%. And this is going to go either on the hot plate or in the oven. Because it's a clay sample, I'm going to put it in the oven. Awesome. Alright, so now what I'm going to do, for the same reason, because I didn't make a whole lot of material, I'm going to do what's called recycling points. So obviously the material in here I just broke up, and I'm going to add it back to my pile. Recycling points is not necessarily a bad thing, and it is not necessarily, and it is not against spec. You can recycle points. Now, where you can get in trouble recycling points is if you're doing like a modified, or you mess something up, or you're running a bunch of points. The reason why is if you start to break down your aggregate, if I had a certain gradation of ag in the first place, every time I run that Proctor, if I start breaking down that rock, it can change the gradation. If you change the gradation, you change the Proctor. So what that means for us is we need to get a big enough sample, or a client needs to provide us a big enough sample to run this gradation effectively. Otherwise, we might have skewed results. For you guys, what it means is if we're out there for you guys on a commercial job or on a state job, on a road, whatever it may be, if we're using a certain type of material and we have a Proctor on that material, if you change the material, it comes out of a different stockpile, you change suppliers, they can call it the same thing, a 303, a road base, whatever you want to call it. It can be the same thing on paper, but if it's a different gradation, if it's a different material, it will have a different Proctor. So that could be super easy. It might mean that the Proctor new material went down, and you might be getting 103% all day long as far as compaction goes. But it also could go up. So if you're sitting there wasting time, you guys got rollers on on your mat, or you get rollers on the job. You're paying somebody like me to come out and do the inspection, do the density control. And I keep on repeatedly failing you guys because it's not meeting the compaction specifications. If the gradation changed and you didn't tell the inspector, that very well could be why. But to get back to the actual lab procedure, I tore out this bowl, I moved it over. I now have 16.89, and I'm going to add 2%. I'm going to try and stair step this 2% increment. So from here on out, I'll be adding 2%. So multiply that by 1.02. I'm now going to 17.22, more or less. What I'm going to do is I'm going to take this, I'm going to add water until I hit 17.2. Just a little more. There we go. So that's close enough to the 17.2. Again, these numbers are not exactly the same, but it does not matter because I need to take a moisture content like I did the first time. So now what I'm going to do is bring this down. I'm going to try to mix it until it's uniform. Again, because this is a clay sample, it's not really going to want to mix very well. It is a pain in the butt, but it is something that we have to do, and it just takes a little bit longer. That's all it is. So I'll be sitting here mixing this until I can get it, until I'm satisfied to call it more or less uniform. So I'll pause it and I'll be done mixing because you guys don't want to watch me mix.